Hello guys. So let's let's do the next part, which is the congenital defects during fetal development. This is now part 2, where we are focusing on craniofacial anomalies. These are the craniofacial anomalies. So these craniofacial anomalies, they are a result of failure of the fusion of the neural crest cells during the formation of the regions of the body. So here we go, there is cleft lip. This is the cleft lip, right? Cleft lip here. So we are seeing that there is separation on the upper lip. The cells are not fused together. That's what we call the cleft lip, and is a result of the failure of the neural crest cells to fuse. The neural crest cells, they are therefore or responsible for the formation of the facial region or the outer skin. So here, during embryonic development, the neural crest cells, they migrate, right? Then they reach to the facial region. They start forming this side and this side. They start forming this side of the lip and this side of the lip. But when they form those sides of the lips, they should fuse together. When they fuse together, they form a complete lip. But when they fail to fuse together, there will be a gap in between because of the failure of those neural crest cells failure of those cells formed by neural crest cells to fuse. So sometimes we say this cleft lip is a result of genetic. Yeah, this is true. There is what we call the Patau syndrome. It is also called trisomy 13. It's a result of extra chromosome X on number 13. So the features of the Patau syndrome are the cleft lip. So meaning the extra chromosome on number 13 causes the failure of the fusion of those cells, or there is a regression of those cells on this side and the other side to fuse due to Patau syndrome or trisomy 13. Now let's go to for this cleft lip. It can be corrected through surgically or by plastic surgery, doing plastic surgery, or just surgically. Let's move to cleft palate. Inside the mouth, there is hard palate and soft palate. The hard palate is that one inside the mouth, in the upper, close to the lips, that region, which is, if you squeeze it, it's hard. The soft palate is down there in the upper jaw. So it's the same principle, same way, or same cause on the cleft palate. So the difference in neural tube defects and this craniofacial anomaly is, in the neural tube defects, there is failure of the neural tube closure, but here there is failure of the neural crest cells to migrate to this region, or failure of the fusion of the neural crest cells. So on this cleft palate, those there is failure of migration of the neural crest cells. Those neural crest cells, they also help in the synthesis of E-cadherin. E-cadherin helps, it acts as a glue, and it helps to join those separate layers inside the hard palate. So if there are no neural crystal cells, there is no formation of E-cadherin, therefore there will be a gap in between. And also the neural crystal cells, they migrate and they to form these, they help in the formation of these layers, and these layers should then fuse, and they fuse with the help of the neural crystal cells. So sometimes there is regression of these cells from this side and these cells from this side. Therefore, there will be no complete, or there will be no joinment of those two separate layers. This is cleft palate. So cleft palate. Sometimes they can be cleft palate together with the cleft lip, and it's corrected surgically. Now let's move to microcephaly. This is now microcephaly. So microcephaly is the same congenital disease, but in microcephaly now, then you found out that there is a problem in the head. The head is short. What happens to microcephaly? So let's finish again. So in this microcephaly, we're talking about the neural crystal cells. The neural crystal cells help in the formation of cartilage, the neural progenitor cells, the nerves which supply the head also. So if the neural crystal cells develop, right, then in the head there may be apoptosis of the neural progenitor cells. So this apoptosis of the neural progenitor cells result in the decrease in size of the brain. Therefore, even the size of the head will decrease, because the size of the head also is due to the size of the brain. The more the brain grows, is the more the head grows, right? So this is microcephaly. Is not related directly to the neural crystal cells, but neural crystal cells are the ones which cause microcephaly. So here we've talked about neural crystal cells. Those neural crystal cells, they cause these defects: microcephaly, the cleft palate, the cleft lip, due to the crystal cells. And we learned that the neural crystal cells are the ones which cause the development of the facial skin, of the cartilage, and also of the nerves, peripheral nerves, and also result in they also produce also the neural progenitor cells come from the neural crystal cells, right? Thank you very much.